So we're not an AGI company. We're not interested in building digital gods. I'm interested in making this technology deliver on the promise it has made and solve real world problems.
Today we are in Toronto. We're in Cohere's office in Toronto. We've been invited to their build day here in Toronto. They're running these in 4 cities, so in Toronto, in San Francisco, in New York and London. And we're going to be capturing the events here in Toronto and in London next week. So a couple of weeks ago, you probably heard about this, Cohere absolutely shocked the market. They released a new set of models called Command R, and these models are particularly good for retrieval augmented generation. Now, we interviewed Patrick Lewis last year in the London offices, and Patrick invented retrieval augmented generation. He wrote the original paper on it. It's a really powerful technology because it allows you to ground language models.
Retrieval augmented generation is kind of a general term these days. It refers to having a generator, a model that generates stuff, usually it's text, and augmenting it, i.e. giving it some stuff that's not just the kind of usual thing that you would put into a large language model to make it better at its task, and you're going to find that augmentation from a retrieval database. So they're often used in situations where you have a large language model or a chatbot, and you want to give it extra knowledge that you have that's external to the chatbot. And so that retrieval augmented generation paradigm is about how to hook up and get the large language model or the AI to leverage that unstructured knowledge that you have via retrieval to better do your tasks, your knowledge intensive or your knowledge-based tasks.
Today we're going to be speaking with Nick Frosst, one of the co-founders of Cohere. Enjoy.
Yeah, so I met Aidan while I was at Google Brain working as a research engineer. Aidan was an intern actually at the time. That's where he was working on the Transformers paper, which is the paper that kind of kicked off this whole thing. So I met him there working in Geoff Hinton's lab at the Toronto office. And I had met Ivan actually while I was a student at U of T. And Aidan had also met Ivan at U of T, but Aidan and I didn't meet there. So yeah. Bit of a serendipity, but yeah.
What was it like working with Hinton?
I really, really enjoyed working with Geoff Hinton. He's where I learned how to. It's like from him where I learned how to do research. He kind of taught me everything I know about machine learning and about research in general. So I was really, really lucky to get to work with him for those years.
Yeah, I can only imagine.
Yeah,
that's amazing. And I also hear that you're in a band.
Yeah.
Tell me about that.
Yeah. So I sing in an indie pop rock band called Good Kid.
Yeah. What kind of music is it?
It's indie pop rock. So we're like somewhere between The Strokes and Panic at the Disco. Yeah.
Interesting. So how is Cohere differentiated from other players in the space?
Yeah, the space has heated up a lot recently. So there's a lot of players, but we've kind of carved out a niche for ourselves by being focused on real world enterprise business solutions. So we're not an AGI company. We're not interested in building digital gods. I'm interested in making this technology deliver on the promise it has made and solve real world problems. So we as a company stay focused on that.
Can you go into a little bit more detail? So what do you mean by AGI? Does AGI imply that it's magic and it's generalizable and it can do everything? And are you saying Cohere is building more pragmatic, specialized solutions?
Yeah, so I think when a company says that they're going after AGI, they're describing a technology that does not exist yet. Right? They're describing some future world in which there are computers that you treat as a person, or that are, go even beyond the capabilities of a person, and are, there's sci-fi visions of artificial super intelligence and all these things. If a company says they're going after AGI, they're saying that's what they're trying to build. It's unclear to me that the technology we have now will get us there. I don't really care about that. I'm interested, and Cohere is interested in making large language models useful for businesses. So that's what we're focused on. Yeah.
I mean, do you think AGI could exist, or do you think it's just not possible?
I think it's possible. I see no reason why it couldn't. I'm not a dualist. I think we might be able to create, some representation of a human mind that functions as one. I don't think we've done that with transformers at all. I don't think we've made transformers are nowhere close to a human mind.
Okay, but if it could exist, would it be a good thing, and why would it not be interesting?
I'm not sure if it would be a good thing. Yeah, I'm not sure. I think that's a really interesting conversation. I think there's a lot of people who think it wouldn't be a good thing. I think there's a lot of people who think it would be a good thing. I don't know. I think we're not close to that at all. And so I like to think about those things from a philosophical perspective. But when it comes to running a business, I'm really interested in making the technology useful to solve these real business problems. And I like philosophical debates, but I like being grounded in reality a lot more. So that's what we're focused on here.
Absolutely.
Yeah.
Well, maybe we'll go philosophical a bit later.
Yeah, happy to, yeah.
Cohere has just made incredible waves with Command R. Can you tell us about that?
Yeah. So we recently released two new models, Command R and Command R Plus. They're similar from the same model family. We just have one that's bigger and one that's smaller. They're particularly good at multilingual retrieval, augmented generation, and tool use. Those are kind of the things we went after. We've open sourced the weights, and they're available on a bunch of the cloud providers. So if you're a builder, I encourage you to download the weights, try it out yourself, try it out on our platform. If you're in an enterprise, try it out on whatever cloud provider you're working with. They're really good at they're really good at real world problems.
And out of those features that you mentioned, is there a particular standout feature that you feel perhaps has the potential to be really big?
Yeah, I mean, I think all three do. If I had to pick one out of the three, I think retrieval augmented generation is the most exciting. I mean, people talk about hallucinations in language models a lot. I'm sure your listeners are familiar. But for those who are not, hallucination in a language model is when you ask it a question and it writes something that is not true, right? It writes something that isn't based on your view of the world. I don't really like the term hallucination, because it implies that there's something the model can do that isn't hallucinate. But really, all large language models do on their own is hallucinate. It just so happens that sometimes that hallucination lines up with with how the world is. But that's kind of a fundamental issue. So we've trained our models to, instead of just being good at memorizing facts that go out of date or that change or something, we've trained them to be really good at taking relevant information and answering based on those things and providing citations so you know where it got that answer. So I think that addresses this fundamental issue. Now you can get a language model as an interface into some external source of truth rather than relying on the internal memory and weights of that model. Yeah.
I agree. I think there's a problem with anthropomorphization, which is that there's no kind of explanation of why the information is there.
Yeah.
It's still interpretive, but it seems, better to me to at least have the citations there so it's clear why the model said what it did.
100%. Yeah. So our model is particularly good at being here's a bunch of documents. Here's what I wrote. This part of this sentence came from this document. This part of this sentence came from that document. And so you can check and see where it got its source of information.
Yeah, that's very interesting. Yeah, because these models, they mimic language so incredibly well that when you just see, generated text, the temptation is to ascribe agency 100%. And, personhood.
I think a lot of the difficulties people have been having with large language models comes from personifying the model to be doing one thing and treating it like it's doing that, when in reality it's doing something quite different. Yeah. So I really like the retrieval augmented generation stuff of all our models, because I think it addresses that fundamental problem.
Yeah. I mean, reflecting on, RAG and the maturity landscape, I mean, how is it changing the way we are building applications?
I think it's changing a lot. Yeah. I think it's making models a lot more usable. When you've set the whole system up, you use Cohere embeddings that are multilingual, Cohere re-rank to improve the search results, and then you feed in those relevant information to the generative model. You can actually start to use that at production scale. You can actually start to, put in your company's internal documentation and get a real answer instead of something that the model just made up.
Interesting.
Yeah.
So we're at one of your build days. You're running 4 build days in 4 cities, and we're here in Toronto, and there's about 80 developers here. Yeah. Tell me about the day, and who are you speaking to today?
Yeah, the build days are something new for us. We haven't done these before, but the first one went really well. This one's going very well, and I'm really excited for the next two. So we have a whole bunch of people from like a variety of backgrounds, actually. Some really experienced, like long-time ML engineers, some more recent, but they're all on the second floor right now working with our new models and working with our open source chat toolkit, building. Well, I don't know what they're building yet. They just started, but I'll be excited to see what they build in the end.
Yeah, it's so interesting because I think there's a last mile problem in building applications with language models. It's easy to put a demo together.
Yeah.
It's very impressive, but there's still a hell of a lot of software engineering, good old fashioned engineering that needs to happen, and just building that developer awareness I think is really, really important. But given that there is still a let's say a 5% robustness problem, what kind of general guidance are you giving to developers? Is it a case that there are general rules, or is it quite specific?
Yeah, well, I think if you're building an application that's like a chat interface to do something, I think it's a really good practice to use the citations in the UI that our model provides, because that really does increase trust, right? Like if you can see where the information came from, then you can know, okay, I'm relying on this. This is good information that the model had. So you mentioned there's a last mile problem. Yeah. I think there are there's a few. One of them was building out good user interfaces to use large language models. So one of the things that they're working on is our chat toolkit. This is like a whole full-featured chat interface that we just open sourced. So now we have something called the Cohere toolkit. You can deploy that locally. You can deploy it. It's all set up for Docker and everything. So you can deploy in your own environment a chat interface using our models with citations, with RAG, with tool use even, Python interpreter, like all of these extra bells and whistles. And that has already gone a long way in setting people up to build new products with this tech.
I'm really excited about the evolution of RAG. So tool use is fascinating, and I think in the future it could be generalized to just discovering, microservices, and doing flexible semantics and so on. But what's the evolution there? Like, what kind of tool use are you seeing now, and where do you think it's going?
Yeah. So right now, so tool use is kind of a new thing people are interested in LLMs, and it's where instead of just getting the model to write some text, you get it to use some tool to like write a query for that tool, and then based on the result of that tool, which is externally computed, give you an answer. So retrieval augmented generation is like kind of the first example of this. Like the tool is a search, and so you get the model to write a search query, do the search. Based on those documents, answer the question, provide citations. That's like one tool. Another tool we have in our toolkit is a calculator. So you can get the model to write a mathematical expression, execute the mathematical expression, give you an answer based on that. That's one thing. Language models are notoriously bad at math, as you would expect them to be, given that they learn by repetition and reading from examples. Yeah. It's really hard to learn math by memorizing every math equation you ever see. So they're really bad at that. So we can augment that by giving them access to a calculator and then answering the question based on the output of the calculator. Those are two kind of simple examples. A third one that we've added into Toolkit recently is Python. So you can use code as a tool itself. The input to that tool is a bunch of code. The output is the output of that code. And that kind of opens it up to everything. So where does it go from there? I think you start combining those. So one thing in the toolkit you can also do is turn on, search as a tool and Python as a tool, and turn on multi-step. So now you can ask a question like, create a graph of the height of the 5 tallest pyramids. And first it will find what are the 5 tallest pyramids, what are their heights, and then it will use Python to create a graph to do that. So you can see how chaining those things together, you could get to a world where you kind of arrive at a computer, maybe the screen is blank, and you just say, do this. And then it figures out how to call various things. If it doesn't know how to do it, maybe Google searches it first, finds an API, builds you a front end to interact with that API. We can get to a point where language really can be the default interface between you and a computer. I think that's really exciting.
That's fascinating because I'm interested in how this is going to kind of evolve over time. So as I understand it right now, Cohere has an incredibly sophisticated, toolkit which generates prompts, which constrains the model, and we can solve problems because even if we run this thing non-interactively, it's going to work reliably. It's going to do, what we need it to do. But when the tools become more open-ended, so let's say it's generating code to do something, and people might be building these agentic meta-programming systems and so on, then it feels like it's harder and harder to run it unsupervised.
100%. Yeah.
What does that look like?
Yeah. So I mean, you can think of this in the same way you think of like game AI or something like chess AI. I mean, sitting in front of these chessboards, you can think of it as the same chess AI or Go AI. Like there's a branching factor to these things, right? Like one of the reasons why the algorithms that beat chess were so different than the algorithms that beat Go is because in chess there's an average of like 80 moves or something you can make per move, and in Go there's an average of like 200. So we had to completely redesign the computer systems that were used to create AI for both of those games, simply because the branching factor is bigger. And if you're gonna, every time you're going to make a move, there's 200 possible moves to make. I don't know what the branching factor for writing Python is, but it's probably pretty big, right? So I think like as you start to do multi-step and do more open-ended tools, it certainly requires more supervision and more correction. Just in the same way that, if you're asking a person to do a simple task, that's one step, you probably don't need to supervise them. They can probably do it. But if you're asking somebody to do a task that requires many, many, many steps, you might want to check in on them every now and again. Yeah.
Yeah, I mean, the way I think about this is it's to do with like the divergence of semantics and understanding. So, because I'm really excited about, agentic systems, for example.
Yeah.
And the problem at the moment is every single step it diverges. So it's moving away from the thing that I wanted it to do.
Yeah.
And I guess you could solve this one of two ways. I mean, maybe if we made it understand better, we could trust it to, work in these divergent flows, and it would still end up doing what we want it to do.
Well, I think here's where we're going to get into some of the like non-AGI things. Like I don't love the term agents, although it has been widely adopted, agent workflows or something. I don't love it. I don't like implying agency to a sequence model. I think that's actually kind of misleading. I think I like to use the term multi-step tool use, because when you say something like that, you can imagine how the problem you're trying to tackle is fundamentally a sequence modeling problem. Like you have some sequence of calls, you've trained a model, a probabilistic autoregressive model on those sequences, and we're going to try to make the model better and better and better at that. You're not going to get agency out of that. It's not going to suddenly get agency. And it's always going to be constrained by the data that it has been trained on. So I don't think these models in a few years will get to a place where you can say something like, "Hey, LLM, run my business for me." That's not going to happen. It's too open-ended. The branching factor is too big. It requires too much about the real world. There's not going to have been data that represents that use case. It's just not going to work. But I do think we could get to a point where lots of little things throughout running a business could be automated by a language model. You could say, "Hey, read these documents and make a report that tells me this information." Like that could probably be done by multi-step tool use. So you could say, "Hey, look at these customer requests and, respond to them with these particular things if this happened," or something. Like you could start to chain things like that together.
Yeah, I think part of the issue with agency is people think that it's just a thing which acts. And I love the definition. There's actually many definitions on the Stanford Encyclopedia of Philosophy, but let's say a system with preferences, with goals, with intentionality, something which is trying to affect the system around it, to achieve its preferred states. And what's to say that a system couldn't have that? It seems to me that the missing component is the understanding. I agree that it doesn't have volition because we tell it what to do. We tell it what the preference is. It doesn't infer the preferences. But let's say, here's a thing that is aligned with us. It has the same intentions as we do as CEOs or something like that. Why couldn't that be an agent?
I think, this is going to get down to like a philosophical discussion on what the definition of agent is.
Yeah.
And I think we can have an LLM that can, based on training data, figure out what tool to call. We can have it figure out how to use multiple tools in sequence, or perhaps even create, sub agents to accomplish goals. Like we could do all of that. Yeah. And I think we will. But fundamentally, these models are still based off training data. They still work on things that they have seen before for the most part. And that means, they're never going to be as robust as you or I are. Like, we are doing something very different than an LLM is doing, even when we're trying to solve the same tasks. And so I think that means there are going to be some things that LLMs are very good at. Like I use this graph example, right? I ask it to go make a graph of the 5 tallest pyramids in the world. That would actually take me a while. Like I would have to Google search it, find it. I'd have to remember how to use Matplotlib, or I'd have to remember how to use Google Sheets or something. It would take a little bit, but you can use our model to do that in a second now, in a few, So there are things that it's going to be very good at, but the things about operating in the real world, operating in, with the complexities and intricacies of interpersonal dynamics that come up when you're running a business, those are probably not things you're going to get from a training data set. And so I don't think these models are going to extend to that.
Yeah. There's also this thing that contra Nick Bostrom, I think intelligence is about goal dynamism. Part of agency is about, the ability to dynamically change your goals.
Yeah.
And having an agent that is explicitly told to do one thing can't be intelligent by definition.
I mean, I think that's another, all of these complicated debates are just like, well, it depends on what you mean by intelligent. I think in some ways those debates, they're interesting, but they don't really help you get to the bottom of it. I think what helps me get to the bottom of it and like understanding where this technology is going back to what it does. And what it does is probabilistically, based on a huge training data set, write a sequence of tokens.
Yes.
That's what it does. That's not what you're doing. You're doing something very different. And so these are obviously these two things, these two technologies, a human brain and a large language model, are going to be very different. It's like lots of people have used the analogy before, but it's similar to like artificial flight, right? Like we have planes, which are incredible and can carry huge amounts of weight, massively long distances. But, they're not the wings of a hummingbird. They can't hover in one place. They can't dynamically change. Like they're very different technologies. Planes are super useful and are, a truly incredible feat of engineering and are a fundamental part of our lives these days. So we created artificial flight. It just ended up being very different than biological flight. And so is particularly good at some things and not good at others, right?
Absolutely. There's this kind of narrative coming from Silicon Valley that LLMs are general. And I think it serves as a useful fiction in my opinion. But I believe that these models are more specialized than people realize. And with that in mind, I mean, is there a future where we might see specialized versions of LLMs? Or do you think there'll always be this idea of a foundation model that is general?
So I think they are really general when you look at like the history of machine learning. So when I first started doing machine learning research, if you wanted to solve any task, the best way to solve it was to create a data set for that task, train a model on that data set, use the model for that one task and that one task alone. That was like where things started. Then in image recognition, shortly thereafter, it turned out that you could actually like have a general purpose kind of image recognition model, and then you could fine tune it on your particular data set or something, and that was helpful. We're now in a place where if you take a really big transformer and you have a language task you want to solve, you might actually get better results by just prompting that general purpose language model than you would on fine-tuning a model based on examples of your task. That's a really interesting outcome. I think that has to do with the perception of the narrowness of language. We think of language tasks as being very constrained. Like I can imagine a task of like, reading a document, reading like a quarterly earnings report and extracting sentiment and, the revenue or something. You might think that's pretty constrained. But when you actually look at the way people write earnings reports, that they're all over the place. They use different turns of phrase. They use different. It's very difficult to get a data set that captures that and that alone. So you're probably better taking a general purpose transformer and prompting it a few times, and you might get better results out of that. So they're general in that sense. I don't think they're general in the way you and I are general. Like I don't think they are as robust as that. And so there are going to be things that they don't extrapolate to and some like fundamental limitations of where this technology can go. But that doesn't mean I don't think they're massively useful, and they're general purpose enough that if you have a language problem, you should probably be using a transformer to solve it, and that will probably get you the best results.
Yeah, I mean, a couple of thoughts on this. I mean, first of all, language might not be as general as we think. And also there's the benchmarks problem. Maybe you can comment on that, but it's possible that there's, like some of these models you could say are cheating because they're kind of training on the test set.
Yeah.
And so, writers in the New York Times or whatever, they say, these things can pass the bar exam. They can pass SATs and so on.
Yeah.
And they're not really passing. But the thing is, they are general for the reasons you just said. They really are general. So what is it?
Well, it's a very, this, as with most things, the answer is somewhere in between, right? The answer is somewhere, they are general, but they're not general the way you or I general. So benchmarks has become a real problem in language modeling.
Yeah.
And that, over the course of the history of this company and this technology in general, like every year there's been a new benchmark that people have cared about. So in our first year, the benchmark that everybody cared about was LM1B, which was measuring a model's ability to generate news from 2012. That was the benchmark that everybody used. After that, it was something called HelloSwag, which was your ability to come up with the ending of like weird sentences about where cups were and like odd kind of things. More recently, it's been MMLU, which is a series of multiple choice questions involving some surprisingly specific things. It turns out there's a lot of questions in there about Sigmund Freud's theories. We use all of these as proxies to understand how good a model is. And like, they give you some intuition, but they're they're easily cheated and normally not at all correlated with what people want to use the model for. Like everybody's measuring MMLU. Nobody building an application with a language model is giving it MMLU-like questions, right? Like that's actually not useful. We don't need a language model to answer weird multiple choice questions. We need it to, help us with our work. We need it to structure unstructured documents. We need it to, call tools based on the input from a user. And like none of those are really captured by the benchmarks that exist today.
Would Cohere ever verticalize, or do you expect customers to build derivative or fine-tune models on top?
So I think our objective has been, to build these general purpose models tailored specifically for business.
Yeah.
A lot of people talk about like, should we make a financial model or a medical model or something? I think actually the way to do that is to use retrieval augmented generation. So we're not going to try to train a model that memorizes all the facts about medicine. We're going to make it generally good at language. And if you want it to know facts about medicine, you can give it documents in the retrieval augmented generation system, and it can answer it based on that. Yeah.
Can you contrast RAG with having a really long context and just putting everything in there or more in there?
Yeah. So we've expanded our context window. Our context window is now 128K for the Command R Plus release. These things are different. So a retrieval augmented generation system, I think when I say that word, a lot of people think like a whole search thing where, you generate a query. With that query, you find some relevant document. You then use an embedding model to measure similarity. You use a re-rank model to refine that. Then you put that back into the prompt. And you might say, well, can't we just put all those documents into the prompt and answer directly without any of the embed or anything? I would still call that a retrieval augmented generation. It's just that your retrieval is really broad. You're saying all of these documents, put them into the context window. No matter how big your context window gets, you're probably going to have, in a production setting, more documents than fit. Like that might not be true if you're building like, I've built retrieval augmented generation systems for like little games where I like give it a bunch of lore or like a backstory and then I answer questions on that. Now I don't need to do embedding or re-rank anymore. I just like put it into the prompt and answer the question. But when we're looking at, real world production business usage, it's like answer this question from all of case law or answer this question based on a person's entire, history or something, like any of these huge things that really quickly go over your context window. Yeah.
Fascinating. I can imagine a world where, let's say in the future, we've got 10 million context window or something like that. And folks using Cohere, it just kind of remembers everything that you've ever done. So, all of your previous interactions are in there. And so you get this kind of divergence. where everyone has a different state. So rather than starting with a blank slate where everyone starts from the beginning, it has, what did I buy for shopping last week and when I went on holiday last year and so on. And my gut intuition is that model would be kind of weird and constrained and quite hard to benchmark. I mean, what do you think?
Yeah. I mean, I think that would get pretty weird. I think the obsession with metrics and benchmarking right now is like a local minimum. Like, I think the obsession with that is because this technology is still so exciting and it's being talked about all the time, and it has yet to really deliver on that promise. Like, I'm starting to see a bunch of people use LLMs as part of their daily workflow and part of their life, but a lot of people still don't. A lot of people have seen this technology as like a cool oddity and then moved on. It hasn't impacted the way we use computers, the way the internet did, the way the touchscreen did, the way the mobile phone did, like any of those, the way databases did, I guess, like any of those things, those technologies, they became like inseparable from the way we use technology and we use computers. Large language models, I think, will do that, but have yet to do it. And now, like, there's benchmarks for touchscreens. Could you name me one? Right? Like, no. Like, it's not relevant anymore, right? Like, you just use the thing. And there's like benchmarks for phones, but like, as a consumer, you just kind of decide which one you think is best and you use it. I think that the obsession with like leaderboards and benchmarks exists because the technology hasn't landed yet. It hasn't delivered on its promise. And when it does, we're not going to be worrying about like, well, hey, does your model, is it great at memorizing facts about Freud's theories in a multiple choice setting? You're going to be like, well, does this one help me solve my problem? Like, it does. Great, cool. That's it. That's what it's going to go to.
But then the question is, has the technology landed? So, I mean, I've got a bit of an intuition looking at some of the benchmarks, and the benchmarks are broken. But there's also things like the the LLM arena, which I think is very interesting, which you can talk to. But it appeared. I mean, like the models are all in a similar ballpark now. Does that mean it's saturating, or do you think that if we put 10x more into data and training, we could still see a huge improvement?
I think that's an interesting question. I think on some of the like benchmarks, like not the, we're saturating because people are training on the test set. So there's some saturation going on there. Yeah. I think in the ELO ranking, I think that's a much more interesting benchmark to me. I think that one's quite interesting. I think the shortcoming of the ELO ranking is that what people want to use LLMs for in business applications is mostly not idle chit chat. It's mostly not asking it a brain teaser and seeing if it gets it. It's mostly work automation or, augmenting systems that are in place already to handle a bunch of, complex language processes or something. So the ELO ranking is cool, but you have to remember it's measuring not how useful is this model going to be for my business. It's measuring how good is it to chit chat with. And those are correlated. They certainly, like a model that is, language models that are really good conversationalists are often really good workhorses as well. So it's a decent one, but it has its shortcomings as well. I think there's still room to grow. Like, I think these models are going to get a lot better over the next few years. What I think that's going to look like is the stuff we were talking about earlier, multi-hop tool use and integrating with systems that are, external to the LLMs. I think that stuff's just going to get more and more and more reliable. I don't know if we're going to make a model that's, even better to chit chat with on ELO, but I know that we're going to make a model that is more useful.
Yeah. Even if it wasn't chit chat, if it was something better than that, you could argue that the benchmark is still kind of human parasitic and human limited, because it's limited by the ability of humans to kind of recognize something as being better. I'll give you chess as an example. Yeah. So, in chess, there are roughly 30 kind of skill floors where, according to ELO, one person in the floor above will beat the person, 100 ELO points below 95% of the time. So there's a massive dynamic range of skill in chess. And I don't think there is such a high dynamic range of skill in humans. And of course, chess is one skill. We have a whole, like a whole 9 yards of skill. But then what you were saying before is interesting, which is that there's a kind of good enough thing, right? Like when it reaches maturity, then at some point it's like the iPhone 15, like it's good enough.
Yeah, that's interesting. I think I think the tech's going to get a lot better in the next little bit. So I don't think I'm excited for our next model release. Like we're cooking up some exciting things.
Oh, right.
I don't think we've saturated on that, but I do think that a person's ability to look at a model and say this one's better than that one based on my brief conversations with it, those don't really reflect the business use cases that people are making. And we've seen, a bunch of research has come out on this recently showing the effect the preambles have on ELO ranking, showing the like slight formatting changes make a huge difference in people's perception of how good the model is. All of those things like kind of show the brittleness of that ranking. I imagine as time goes on, we'll get better at making the ranking as well. So hopefully we can have one that reflects like, hey, we want the ranking to say, if you're going to solve a business problem, you're going to use a model to do something within your work. This one's going to solve it for you. This one's going to solve it for you. This one's not. Like that's what we'd like to get to. And we're not really there either. So I expect the models to get better and hopefully the way we evaluate them to get better as well.
Yeah, it's interesting the comment you made about almost human adversarial examples that, you kind of like change a couple of things and humans see it completely differently.
Yeah.
I'm interested, you probably can't talk too much about this, but how is Cohere differentiated in terms of like your data acquisition pipeline and how you kind of like get all of the data prepared for the language model?
I don't know the way other companies are getting their data, so it's hard to talk about the ways in which it's differentiated. I know that we make a point of getting data where we can do so reasonably. We make a point of getting data where we're confident in its usage. So that's that comes from our focus on and business enterprise. So we do like data indemnification. So if you're using our model, we can indemnify you against that. And that comes from our, belief in our principled approach to data acquisition.
Yeah, I'm a huge fan of Sarah, of course, who runs Cohere for AI. Mm-hmm. And, the ethical question is really, really big here, because I know you folks have done so much around, like the multilingual model, mm-hmm. and, looking at low resource languages and, mm-hmm. and stuff like that. But it gets to the point when you're playing the SOTA chasing game, you almost like, do you take a principled stand and say, oh no, we actually want to have fairer models, even though some of our headline, metrics might not look better? I mean, where do you kind of think about that?
Yeah, it comes from trying to make a model that can be deployed anywhere and that any business can be confident deploying and using. Yeah. Like that's, if our objective is to make a useful thing for businesses, then how we handle data like falls out of that naturally, right? Like that. Yeah.
We're not really building custom machine learning models anymore. The data science function, as a role, it rose to prominence around 2017, and loads of folks building custom models. And it feels to me that now there's more of a software engineering focus. There's this like, let's use foundation models, let's do LLM ops. Is that a fair assessment, or do you still think there is huge, importance of data science?
Well, look, the time period you're talking about, like 2017, 18, when people were a bunch of ML engineers making custom models, they weren't doing language as a modality. Right, they were doing, like predictions of image classification, or they were doing predictions of outcomes based on numeric features or something. And none of that has changed. Like that's all still happening. Everybody was doing that. They're still doing it in some form. It's just that a whole new thing has opened up of like, oh, you have a language problem to solve? Cool. A transformer, a large language model can help you solve that. So I think all of those things are still probably ongoing. We just don't talk about them as much anymore. Yeah.
Yeah, but how would you contrast them? Because it feels like a difference in kind. So one feels more like software engineering, and it feels more like composing, like in software, you compose modules together. There's still a whole bunch of metrics around it. So you could argue it's a similar mindset, but it feels like in those days, it was, it was different. It felt like R&D. It felt different. Now it feels more like it's just software.
Yeah, well, I would I would imagine that actually it always feels like software engineering, and that even when we're thinking back of the days of like 2018, when somebody at some company was told to train a neural net to predict click-through rates of something, the challenging problems in getting that running was software engineering. In the end, it was like, okay, cool, I'm going to do some feature engineering for a bit, and then I'm going to spend a long time figuring out how to get this system ready in production and like actually working. So I think now it's a lot of the same stuff, You spend some time figuring out how to get a good prompt. You spend some time looking at which model's particularly good at your task. And then you spend time as a regular software engineer building out the infrastructure to actually run it. So I bet they're not that dissimilar.
I mean, I agree with you. So I always thought of software engineering as being hugely important to get models into production.
Massive.
But there was this kind of impedance mismatch. So the data scientist would build the model, and then you'd hand over to the ML engineer. You build this DevOps pipeline, and it was always like super brittle because what happens when the model changes? And now the difference, it seems to me that a software engineer on their own can do the whole thing.
Yeah, I mean, I think now that we're all back-ending our stuff based on a pre-made model, it does mean that you don't need to you're not doing feature engineering, you're doing a little prompt tuning, you're doing some prompt engineering. But that's a thing, you're not taking some weird, you're not applying some weird function to a numeric value and noticing that if you apply this function, that's a better feature than this one. You're just toying with language a little bit. And that's a thing that's a lot more accessible. Yeah.
Amazing. Is there anything else you want to talk about?
I want to shout out our open source release of the toolkit so that any of your developers, if they're building chat interfaces, I highly recommend that they check out our GitHub and use the Cohere toolkit for building chat interfaces with tool use, multi-hop tool use, including things like Python interpreter and web search. So try that out and check out the new Command R Plus model. It's really great. I use it a lot. It's my go-to these days.
It's amazing.
Yeah, and it's good at tool use, retrieval augmented generation, and multilinguality.
Nick, it's been an absolute honor to have you on. Thank you
so much.
so much.
Yeah, thanks so much for having me. I really enjoyed the conversation.
Amazing.